Hello everyone. So here we are going to learn rate of change of momentum. Now when we talk about rate of change of momentum, then only one formula comes, that is in A. This we all know, but here we are going to see how did this formula come. First of all, what is momentum? If we multiply mass of an object with the velocity, then the product is going to be your momentum. So what is momentum? Mass into velocity of an object. Now here are some assumptions. We are applying a force which we have assumed to be F. The mass of the body be M for time t seconds, and initial velocity we have taken as u, and the final velocity we have taken here as v. Now if p represents momentum, okay, p symbolically, or it's an yes, it's a symbolic representation of momentum. So when we talk about initial momentum, then mass into velocity. So initial velocity has to be taken here because we are talking about initial momentum. So what is the initial velocity? U, so mu. Final velocity, what is the final velocity? V. So final momentum is what? Mass into final velocity, so mv. Now we are going to find change in momentum in t seconds, right? If we have to find out the change in momentum, that means t seconds is the time interval. If we are to find out the change in momentum, we have to subtract mu from mv. That will give us the change. So final momentum minus initial momentum. What we are doing, we are taking out m common. M we are taking out common. So in the bracket what lies? V minus u. Now we are finding rate of change of momentum. Now know one thing, in physics, wherever the term rate comes, in 99.9999 cases, whenever the word rate comes, the particular thing means, suppose your rate of change in momentum. So we are going to divide change in momentum by time. So whenever the term rate comes, we divide by time. Simple. Okay. So change in momentum, what was our change in momentum? M into v minus u, and time already taken here as t. Now what we are doing? We are actually taking this as a separate thing. Okay. All are in multiplication form. So v minus u by t. Now v minus u by t is actually the formula of acceleration, right? So this v minus u by t can be represented by a, representing what? Acceleration. So ultimately rate of change of p, that is momentum, is coming here as in a, that is mass into acceleration of the body. Force is also equals to ma, but that is a different story. Here it's a different story. Do not confuse yourself. But yes, rate of change of momentum is